Hello everyone, this is Jyotsna. Welcome back to my YouTube channel. In this tutorial, we will see the one of the type of design patterns. We have already seen one type which is singleton design pattern, and I have already uploaded that video. And today we'll see the prototype design pattern, which is also another type of creational design pattern. Before starting, let's start with the introduction with the design pattern. So design patterns are nothing but some reusable solutions to common problems and that arises during software design and development. And these patterns provide general solution guidelines and templates to help developers solve recurring design problems in their software applications. So with GOF, we have three different types of main design pattern: creational, structural, and behavioral. Creational design pattern deals with the process of object creation, while structural design patterns deals with the composition of object structure. And behavioral design pattern deals with the process of communication, relationship, and responsibilities between objects. So these are the main part or main type of design patterns, and again these design patterns divides into different several subparts. So in the creational design patterns is divides into five different types: singleton, factory method, abstract factory, builder, and prototype. We have already seen the singleton. Today we will see the prototype design pattern. So let's start with some introduction on prototype design pattern. So it's one of the type of creational design pattern, as I said, and the prototype design pattern is used to create a duplicate object or clone of the current object to enhance the performance. So the concept here is copy the existing object rather than creating a new instance from the scratch. As the name suggests, prototype. Prototype means copying existing, whatever the object we have, right? So this is mostly used when there are some costly operations involved while creating new object. And this pattern is used when um, we want to copy the existing rather than creating a new instance from scratch, as I said earlier. So one of the best available way to create the object from existing object is to using the clone method, right? You can already have one object and use the clone method on that object and create a new object from that, right? So it is used when the, as I said, it is used when the creation of object is costly or complex, time consuming. That time we can use the prototype design pattern. Let me start the slideshow. Yeah, so when to use, as I said, um, so there why we use prototype design pattern or when to use prototype design pattern. The cost of creating an object is more expensive or complex than copying an existing object. That type we can use the prototype design pattern. Also, a limited number of state combination exist in an object. So reducing database calls. In scenarios involving heavy database operations to fetch object states, a prototype can be used to reduce these operations by cloning preloaded objects. And next is the scenarios where many similar objects are needed. It's more efficient to clone a prototype than to create each object from scratch. So some of the applications of the prototype design patterns are: first is object cloning. So one of the use case for the object cloning is when you need to create an exact copy of an object, especially if the object has a complex construction process, or if creating it from scratch is expensive. As I have already told how we do the object cloning. This is one of the application for the prototype design pattern. One of the example for object cloning is in graphic applications. So you might have a complex shapes like a polygon or a 3D model that can be cloned to create a new shapes, right? So another one is configuration management. So when objects have a lot of configuration parameters and you want to clone a pre-configured prototype instead of setting up a configuration from scratch each time, that time we can use prototype design pattern. So for example, in software configuration tool, you might have a default configuration object that is cloned and then modified with different environment or users. The next is caching. So caching is one of the other application for where we use the prototype design pattern. So one of the use case is to implement the object pooling or caching mechanism where the cost of creating new instance is high. For example, in a game, you might use prototype to cache and reuse objects like any enemy units or environmental features that are frequently used but expensive to create. So that is one of the example. Next one is version control. So when you need to keep the track of different versions of an object and switch between them easily, that time you can use prototype design pattern. One of the example in software development environment is different versions of the configurations or settings objects can be managed using prototypes, right? So next is resource management. So resource management, here we use prototype to manage resources efficiently, particularly when the resources are costly to initialize, right? One example is in a simulation on a, or a large scale data processing system, using prototype can help in manage and reusing complex data objects or simulations. The next is product customization and undo mechanism. So product customization, here we create customized version of product where the base product is the same but specific attributes are varied. And with undo mechanism, to implement an undo mechanism where you need to keep a snapshot of the state of an object, that time we can use prototype design pattern. For example, for this undo mechanism application is one of the example is text editor or drawing applications. You could use prototype to store the state of the document or canvas so that changes can be undone by reverting to the previous prototype. Let's go to the next slide. So these are the some of the applications, and let's see one problem statement, why we need to use the prototype design pattern. So let's say we have an object and you want to create a same exact copy for that object, right? So first, what we can do while creating the object, same object copy. First, you must create one new object, right, for the same class. So this is one of the class with the one object. Now we have to create new object of the same class. Then you have to go through all the fields of the original objects and with their values to the new objects, right? This is okay, but what if not all the objects can be copied that way, because some of the objects fields may be private for that object, and we cannot copy the private object into the new object, right? So that is not visible from outside of the object itself. Since you must know the object class to create a duplicate, your code becomes dependent on that class, that particular class. So sometimes you only know the interface that the object follows but not its concrete class. So how to solve this issue, right? Solution is prototype design pattern. So prototype design pattern delegates the cloning process to the actual objects that are being cloned. Means whatever the object we are cloning, just delegate the cloning process to the actual object. And the pattern declares a common interface for all the objects that supports the cloning. This interface lets you clone an object without coupling your code to the class of the object. And usually such an interface contains a one single method, which is clone method. And the implementation of the clone method is very similar to the other classes. The method creates an object of the current class and carries all of the fields values and the old objects into the new one. So here you create a set of object configured in various ways. When you need an object like the one you have configured, you just clone a prototype instead of constructing a new object from scratch. So let's see, the next is yeah, before going through the main how we do the prototype, how we implement the prototype design pattern, there are some concepts we need to understand, right? One of these object cloning. So how it happens in C sharp, one of the example I'm giving here in C sharp language. So when we talk about object cloning in C sharp, it means it is all about the call by value. So if we change one object, it will not affect the other. And to do so, C# provide one method. So C# have inbuilt method which is member-wise clone, which will create a new complete copy of the object having a different memory. So means member-wise clone is a shallow copy of the object. So here we can see this in this example we have the employee class, and we are creating the first copy, means first emp1, this object we are creating for this employee class, and then we are assigning some values for the fields in this class like name and department. And then again, now what we want to do, create the second copy of this employee class. Now this time we are not creating the new object for the employee. This time we are calling the get clone method from this employee class. This is the, here we are calling this get clone method from this employee class. And how it is working in this get clone method, we are returning the member wise clone method. We are calling this member wise clone method to create a brand new copy of the object which is clone, right? So we are directly calling this memorize clone method here, which is a inbuilt in C#. So some of the points which we need to remember while using the memorize clone method, that this method is a part of the system.object class and creates a shallow copy of the given object. Memorize clone method only copies the non-static fields of the object of the new object. And in copying, if a field is a value type, a bit by bit copy of the field is performed. If the field is reference type, a uh, reference is copied, but the object is not. So what is exactly shallow copy and deep copy, we can look into that next. Yeah. So shallow copy creates a new object but does not clone object referenced by the original object. It copies the references rather than the actual object. So one of the example is the object contains a reference to the other object. A shallow copy will copy only the references and not the reference object themselves. So the as we have seen, the member wise clone method is in C# is a shallow copy. It copies the value of the field of the object to the new object. Now what is deep copy? So if our object has reference type field, you might need to implement deep cloning, right? So one object is there which have the references to other objects also. So that time we have to do the deep cloning while creating the clone to avoid sharing shared references in your clone object. So deep cloning involves creating copies of the object referenced by the fields. Example, if an object contains a list of other objects, a deep copy will create copies of the list items as well. Next is components of prototype design pattern. Before that, let's see the generic class diagram. So you can see that in this class diagram, we have client, and client will create the call the clone method on the prototype. So we have the prototype interface, which will always have the clone method of type prototype, whatever the interface prototype. And then for prototype, we will have the concrete prototype. One example is we have this concrete prototype, which will always return the type prototype and which will implement the clone method. Now this will have some field values and return a copy of this. With clone, we will return the copy of this class. Now client will call the prototype dot clone method for the type of prototype interface. So different components are interface prototype, the concrete prototype, client, and the clone method. So let's see. Prototype interface which declares the method of cloning itself, and it can be interface or an abstract class. It defines the common interface that concrete prototype must implement, ensures that all the prototypes can be cloned in a consistent manner. The main role is to provide a blueprint of for creating new objects by specifying the cloning contract. It declares a clone method which concrete prototypes implement to produce copies of themselves. So in concrete prototype, we will implement this clone method declared in the prototype interface, providing the cloning logic specific to that class. It defines the details of how the cloning process should be carried out of the instances of the class. Again, the clone method which we implement, which is another component, this is declared in the prototype interface or abstract class and specifies how an object should be copied or cloned. And the concrete prototype implement this clone method. And the fourth one is client, which creates a new object by asking prototype to clone itself. So these are the four main components of prototype design pattern. Next is some of the generic use case scenarios where we use the prototype design pattern: graphics and drawing application, as we have already seen, game development, configuration management. The advantages, most important advantages is performance improvement, because we are not we are cloning the objects, we are not creating any new objects which is uh, uh, from scratch, but we are cloning the objects, and which is more efficient than creating a new instance, especially if the object creation process is resource intensive. And the reduction of object creation cost. Some of the disadvantages: complexity, because implementing cloning correctly, specifically for deep copies, can be more complex. And the inheritance issue: properly implementing the clone method can be challenging in cases involving complex inheritance hierarchies.